Hello guys, today we will start chapter number 2 of the part 1st of the course Quantitative Aptitude and Reasoning, that is Permutation and Combination. Viewers, permutation and combination are very important and valuable concepts, and these concepts are asked in about all of the competitive examination and departmental test for admissions and different institutes including colleges and universities. Viewers, permutation and combination is equally important and applicable in almost in many subjects like mathematics and sciences, including physics, chemistry, and bio, and statistics, and economics, and many more. Now let's define permutation. So permutation is the different arrangements which can be made by taking some or all of the given things or objects at a time. So in permutation we take different arrangements of the given things. And the definition of combination is different selections which can be made by taking some or all of the given things or groups or objects at a time. Then this is called combination. The only difference between permutation and combination is that and permutation orders is important, and in combination order doesn't matter. That is, order is not important in combination. For example, if we have three elements 1, 2, 3, then this is one combination of three things 1, 2, 3. If I write 1, 2, 3, 1, 3, 2, 2, 3, 1 and any other order, then all that means just three things, that is one combination. But their order will be changed if I write 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2 and 3, 2, 1. So these are 6 different arrangements but only one combination. So this is the difference between arrangements and selections. Now in this example we have three things but it has only one combination and we have 6 arrangements. So it means that permutation is 6 times more than or greater than combination, right? Okay, for combination, for permutation we use the formula NPR. P for permutation, N are the whole things or given things, and R is the arrangements taken out of the N things or the selection out of N things. So this is written as NPR. N is the superscript and R is the subscript. Okay, and this is equal to N factorial divided by N minus R factorial. This is the formula for calculating permutation of given things. Okay, NPR equals to N factorial over N minus R factorial. What is factorial? Factorial is the product of n consecutive positive integers beginning with 1, and it is denoted by this symbol n factorial or this symbol, and is read as factorial of n or n factorial. So n factorial equals to the product of n and all positive integers less than n up to 1. So this product is known as n factorial. N and less than n is n minus 1, then is n minus 2 up to so on, n minus 3, n minus 4, so on, and in the last 4, 3, 2 and 1. So the product of all these positive integers up to n is known as n factorial. If instead of n I have 5, then we write 5 less than 5 is 4, then is 3, then is 2, and this is 1. So 5 factorial means the product of 5 and less than 5 further to integers. So it means that it equals to 5 4s are 23s are 62s are 120, 1s are 120. So 5 factorial means 120. Similarly, 4 factorial is 4 3 2 1. So 4 3s are 12, 2s are 24. So 4 factorial is 24. 3 factorial is 3 2 1 is 6. 2 factorial is 2 and 2 1 is 2. Okay, so please memorize these concepts. Similarly, 1 factorial is 1 and 0 factorial is also 1. Its proof is given in higher mathematics and statistics, but it's not our concern now to prove that how 0 factorial is 1 and 1 factorial is 1. You have just to memorize these factorial by heart. It's enough. Okay, because these factorial are to be used in the formulas of permutation and combination. Okay, we already know that permutation formula is NPR is equal to n factorial over n minus r factorial. Now in the example number 1, we are asked to find out 6p2. Okay, 6p2. So by formula n factorial or n minus r factorial, by instead of n we have 6. So here n minus r 6 and instead of r we have 2. So 6 minus 2 factorial. So this will become 6 factorial over 4 factorial, and 6 factorial can be written as 6 5 and 2 4 factorial over 4 factorial. So 4 factorial and 4 factorial will be cancelled out and we remain with 30. So 6p2 equals to 30. Similarly, 8p3 equals to 8 factorial over 8 minus 3 is 5 factorial. 8 factorial can be written as 8 7 6 5 factorial over 5 factorial. 5 and 5 factorial will be cancelled out and we remain with 8 7 are 56, 56 6 are 335, 336, sorry. Okay, so this is the concept of permutation. Now combination is the different selection or groups which can be made by taking some or all of a given number or things at a time is called the combination. And I already told that in combination order is not important and combination is less than 6 times of permutation. Okay, so permutation combination is denoted by NCR and it will be equals to n factorial over r factorial into n minus r factorial. Okay, the only thing which not comes in the formula of permutation is the r factorial. Otherwise the formula for permutation and combination are same. In the permutation formula we have n factorial over n minus r factorial, and in the combination we have n factorial over r factorial into n minus r factorial. Okay, there is a note that is total number of arrangements equals to total number of groups or selection into r factorial, where r is the number of objects in each group or selection. Let's write this in numerical form, that is total number of arrangements. It actually means NPR permutation. It is equal to total number of groups or selection. Groups or selection mean this is combination NCR into R formula. That is permutation is equal to combination into R factorial. NCR is actually n factorial over r factorial into n minus r factorial. Okay, multiplied by r factorial. So r factorial and r factorial will be cancelled out and we remain with n factorial over n minus r factorial, and which is actually equal to NPR. So total number of arrangements equals to total number of groups or selection multiplied with r factorial. Okay, now in this case we are given 5 different objects P, Q, R, S and T, and if we form a group of 3 objects out of these 5 objects, so then we have 10 such combination or 10 such groups or selection. that is PQR, PQS, PQT, PRS, PRT, PST, QRS, QRT, RST, and QST. And each of these three objects can further be ordered in 6 different ways. If I take PQR, so this PQR is written as PQR, PRQ, QPR, QRP, RPQ, and RQP. So each of these three objects can be ordered in 6 different ways. So there are 10 objects, and we further group each in 6 different ways. So total numbers are 10 multiplied into 6, which is 60. So the permutation for these 3 objects out of 5 is 60, and its combination is only 10. So permutation is 6 times more than combination. Okay. 5. In this problem, we are asked, you are given with 4 different color pencils. You have to select 2 of them at a time. Then in how many ways you can make such a selection? Now in this problem, the word selection has been used. There are total 4 different color pencils, and we have to select 2 of them at a time. So for this we use the combination formula, that is NCR. Now instead of N we have 4, and instead of R we have 2. So we can write this as 4C2, and this will be equals to 4 factorial, where R is 2 factorial, and N minus R is 4 minus 2 is also 2 factorial. So 4 factorial can be written as 4, 3, 2, and 2 factorial means 2 and 2, 2. So this 2 cancelled out with this. This 2 1s are 2, 2 2s are 4, and 2 3s are 6. So the required number of selections are 6. Okay. In the next example, 6, you are supplied with 6 different color balls, and you have to select 3 of them at a time. And how many ways you can make such selection? Now there are 6 different color balls, and we have to select 3 of them at a time. This is again a selection problem, so that's why we use combination formula. So total are 6 balls, and we have to select 3 of them. So we use 6C3, and this is equal to 6 factorial over 3 factorial, and into 6 minus 3 is also 3. So again 3 factorial. 6 factorial means 6, 5, 4, 3 and 2. 3 factorial means 3 and 2, and 3 factorial means again 3 and 2. So 3 2s are 6 will be cancelled with this 6. This 2 3 will be cancelled with this 2 3. So we remain with 5 and 4. So the product of 4 and 5 gives us 20. So the required number of selections, if 6 different color balls and we have to select 3 of them, is 20. Now example number 7. In how many ways can the letters of the word perfect be arranged? Now this is a 7 characters word, in which E comes twice and all other alphabets comes once. So this type of problem can also be solved by just we have to use the permutation. This is also actually the problem permutation, but in this case, for easily convenience, we use factorials. So there are 7 characters, so we can write this as 7 factorial. Now E comes twice, so we divided by 2 factorial, and all other letters are 1, so we write instead of P is 1 factorial. For R we write 1 factorial. For F I write 1 factorial. For C is 1 factorial, and for T is also 1 factorial. So if 1 1 multiply with each other again gives 1s, and 2 1s are 2. And 7 factorial means 7, 6, 5, 4, 3 and 2, and it will be divided by 2. 2 will be cancelled with 2, and if we multiply all these numbers 3 up to 7, we get 2520 is the required ways. Okay. In the next example number 8, in how many ways can the letters of the word engineer be arranged? Now the word engineer contains 8 characters, so its letters can be arranged in 8 factorial ways. But also in this 8 characters word, some alphabets are repeated, that is E comes 3 times and N comes 2 times, so that's why we divide 8 factorial by 3 factorial and to 2 factorial in order to get out the required number of ways. So total are 8 factorial, and this can be divided by 3 factorial and to 2 factorial. So 8 factorial can be written as 8, 7, 6, 5, 4, 3 and 2, and 3 factorial means 3, 2 and 2, 2. So this 2 will be cancelled with this 2, this 2, 2s are 4, and this 3 will be cancelled with this 3. So 2 5s are 10, 10 6 are 60, and 8 7s are 56. So 0, 6 6 are 36, and 6 5s are 30 plus 3 is 33. So the required number of ways to arrange the word engineer is 3360. Okay. There are two important principles of counting. These are called fundamental principles of counting. The first one is multiplication rule and the other is addition rule. Okay, for this I have taken some example. For example, a person wants to go from place X to place Z through place Y. From X the person can go to Y either by bus or by train only. So there are two choices for the person to go from point X to point Y. And there is no, and from Y the person can go to Z either by train, bus or aeroplane. So there are 3 different ways to reach from point X, from point Y to point Z. So the total number of ways to reach from point X to point Y is to point Z is 6. So this is known as principle of multiplication or multiplication rule. Okay. Addition rule. For this I also take some example. If there are 2 events and each event can be completed in m and n ways maximum possible, then the maximum number of possible ways by which both events are completed will be m plus n ways. For example, there are 20 men and 12 women in a conference. Each man and women shakes their hands only among them. Find the maximum number of handshakes that has taken place at the conference. In this example, we are given that there are 20 men and they shake their hands only among them. So this can be found by the formula 20C2, and this will be equal to 20 factorial over 2 factorial into 20 minus 2 is 18 factorial. This can further be written as 20 into 19 into 18 factorial over 2 factorial into 18 factorial. So this 18 factorial will be cancelled with this 18 factorial. 2 1s are 2, 2 10s are 20, and 10 19s are 190. Also we are given there are 12 women and they shake their hands only among them. So this can be found by 12C2. So 12 factorial over 2 factorial and to 12 minus 2 is 10 factorial. 12 factorial can be written as 12 11 into 10 factorial over 2 factorial into 10 factorial. So 10 factorial will be cancelled with this one. 2 6 are 12 and 11 6 are 66. So there are 66 ways to shake hands among them. This is for women. So total number of men who shakes hands among themselves is 190, and for women this is 66. So total numbers are 190 plus 66. This is by using the rule of addition. Okay. Okay, this is important note. You have to memorize these notes and to write them in your notebooks. The first one is the number of arrangements of n different things taken all at a time equals to n factorial, and the number of permutations or arrangements of n different things taken all at a time when each thing can be repeated any number of times is. Okay, if a repetition is not allowed, then we use the formula for permutation is n factorial over n minus r factorial. This is for when repetition is not allowed and the arrangements are in permutation. And when repetition is allowed, then we use the formula n power r. These formulas are for permutation or arrangements. Be careful. Okay, now this is important example and a little bit tricky example. And this example 9, suppose 4 digits 2, 4, 6 and 9, and you have to make a 4-digit number, and how many ways it can be done. If repetition of digits is allowed, repetition of digits is not allowed. Now we are given 4 digits and we have to make a 4-digit number using these 4 digits. Now there are two cases, if repetition allowed and repetition is not allowed. Okay, if repetition is allowed, then we use the formula n power r, that is 4 power r, and this will be equal to 4 power 4, and which further equals to 256. And if repetition is not allowed, then we use the formula n factorial over n minus r factorial. N factorial is 4 factorial, and n minus r means 4 minus 4, which is 0 factorial mean 1. So 4 factorial is equal to 24. So if repetition is not allowed, then by using these 4 digits we can make 24 digits of 4-digit number. And if repetition is allowed, then we have to make 256 4-digit number using the given 4 digits number. Okay. Okay, and example number 10. How many numbers of 5 digits can be formed with the digits 2, 4, 6, 8 and 9, provided that the repetition of digits is not allowed? Now in this example we are given that a repetition is not allowed, and we know if repetition of digits is not allowed, then we use the formula n factorial over n minus r factorial. Now n is 5, so 5 factorial, r is also 5, so we can write 5 minus 5 factorial is 0 factorial, which is equal to 1, and 5 factorial equals to 120. So if repetition of digits is not allowed, then we have 120 ways to make a 5-digit number using the given 5-digit numbers. Okay, if repetition of digits was allowed, then we use the formula n power r, that is 5 power 5, and it is equal to 3125. Okay. Okay, the next example is how many numbers of 4 digits can be formed with the digits 0, 1, 3, 4 and 6. Okay, now we are given 1, 2, 3, 4 and 5 digits. We are given 5 digits and we have to make 4 digits numbers. Now in box 5, this box can't be filled with 0 because it's meaningless to start a number with a 0. So the box 5 can be filled with 4 P1 ways. Okay, and box 4 to 1 can be filled with remaining 4 numbers and 4 factorial ways, that is in 24 ways. Therefore the required number of ways are 24 into 4 equals to 96 by using multiplication rule. In example 12, how many even numbers of 3 digits can be formed with the digits 0, 1, 2, 3, 4 and 6? Now we are given 6 digits and we have to form 3 digits numbers, 3 digits even numbers. So even numbers are all those numbers which are divisible by 2 or multiples of 2. So in the unit place we must have 0, 2, 4, 6, 8 and so on are the multiples of 2. If in the unit place these numbers are present, then the given number will be even number. Now in case 1, when 0 occurs at unit place, then what will happen? When 0 occurs at unit place, then box 1 is filled with 0, that is in 1 way, and box 2 can be filled in 5 P1 ways with the remaining 5 numbers, and box 3 can be filled with remaining 4 numbers. So the total number of ways to fill these 3 portions or 3 boxes are 1 into 5 into 4. So this is equal to 20. So in 20 different ways this can be filled by using the first case when 0 occurs at unit place. Now when 0 does not occur at the unit place, then the first place can be filled in 3 P1 ways, that is the numbers other than 0, the even numbers other than 0 are 2, 4 and 6. So at the unit place either this here will be 2 or 4 or 6. So there are 3 different ways to fill this box 1. Okay, now the box 4 can be filled in 4 P1 ways. Okay, one number here, so the remaining 4 numbers can be this box 3 can be filled in 4 P1 ways, because 0 cannot be filled in that box and the unit place is already occupied, so we remain just 4 numbers. Okay, so the box 3 can be filled in 4 P1 ways, that is 4 ways, this box. Similarly, the box 2 can also be filled with 4 ways, because the box 1 is filled, the box 3 is filled, so 2 numbers are gone. Now we remain just with 4 numbers, so box 2 can be filled with 4 numbers. So this can also be filled with 4 ways. So the required number of ways to fill these 3 boxes is 3 into 4 into 4. So 3 4s are 12, 12 4s are 48. And there are 48 ways to fill this box when 0 not occur at the unit place. Now by using addition rule, we can write 20 plus 48, which equals to 68. So by 68 different ways, we can find 3 digits even numbers using the given 6 digits. Okay, this is a little bit tricky and interesting example. Okay, in example number 13, how many numbers greater than 2000 and less than 7000 can be made with the digits 0, 1, 2, 4, 5, 6, 7 and 9, provided that the repetition of number is not allowed. Now this example, repetition is not allowed and you have to solve this by yourself. Similarly, in example 14, how many words beginning with the word vowels can be formed with letter of the word equator? Now there are 4 vowels in the word equator, that is E, U, A and O. So box 1 can be filled in 4 P1 ways, because we have to form words starting with vowels. So there are 4 vowels, so there are 4 ways to start the words. And remaining boxes 2 to 7 can be filled in 6 pictorial ways, that is 720 ways. So the required number is 4 into 720 is 2880. Example 15. In a party, every person shakes hands with every other person. If there was a total of 171 handshakes in the party, find the number of persons who are present in the party. So this is the problem of combination. You have to solve it by yourself. Example 16. How many words can be formed with the letters of the word enterprise? Now there are 10 letters in the word enterprise, out of which E occurs 3 times, R occurs 2 times and the remaining R comes once time. Now the required number is 10 factorial over 3 factorial into 2 factorial, which results 30,000, 302,000 and 400. Okay, in example 17. And how many ways 7 girls and 6 boys can be seated in a row such that they are in the alternate position? So there are 13 positions, 7 girls and 6 boys, and they are seated in alternate position as shown. You can see here, this is their position. Now the 7 girls can be arranged in 7 places and 7p7, that is 7 factorial ways, and 6 points can be arranged in 6 factorial ways. So the required number of ways are 6 factorial into 7 factorial, which gives us 362,8800 ways. Okay, so this is the end of this topic, permutation and combination, and I think you learned this concept in a detailed manner. I explained each and everything with examples in a little bit easy manner, so that you understand this concept. In this video you learned what is the difference between combination and permutation, what are the definitions of permutation and combination, what will formula we have to use when repetition is allowed and repetition is not allowed in the case of permutation, and what are the principles of counting, that is multiplication rule and addition rule. Okay, thanks for watching this video and sparing your precious time.